Well, so welcome you all to the next video of S.J.Sarkar's basic electrical engineering classes. So now we'll be discussing something about the experiment that we often used to do in basic electrical lab, that is the power measurement in series RLC circuit. In the last video actually you had seen that the power measurement in AC circuit, it would be basically the active power measurement, reactive power measurement and apparent power measurement. So since the name is power measurement, so what basically we'd be trying to do, we'd be finding out the three powers, that is active, reactive and apparent power in this particular arrangement. So traditionally there is this method. We are using ammeter, voltmeter and wattmeter to find out the power measurement and power factor. We would be finding out, and that for that the arrangement would be something like that. We are having the supply, we are having the RLC, they are connected in series. We are having an ammeter to measure the ampere, that is the current passing through RLC, and we are having the wattmeter to find out what is the wattage consumption or the active power consumption of the circuit. So we know in wattmeter we are having the two coil, potential coil and current coil, as shown here. The upper one would be the current coil because the entire current would be passing through it, and the lower one would be potential coil because we would be applying the full voltage across this potential coil. So while going to this particular experiment, what we are actually doing, this is the most simplified arrangement which is used everywhere for this power measurement. So what is being done here, that we are actually directly finding out, let us suppose VL be the voltmeter reading, IL be the ammeter reading, and PL be the wattmeter reading. Now, what is known to us? We know that this active power P is nothing but VI cos phi. Now, in this arrangement, we know what is wattmeter requirement, what is voltmeter, ammeter. So, from that we can write cos phi equal to PL by VL IL. So we are finding out cos phi because we know already the active power. Now once we are getting this this cos phi, which is the power factor, so from that we can find out sin phi, that would be nothing but root over 1 minus cos square phi. Now once we know sin phi, so we can find out the reactive power, that is VI, that I could say VL IL sin phi. And what about the apparent power? That would be VL IL. So that is the way, we could find it out. And for the sake of simplicity, we are using this method. Now, a case may arise that we are not having wattmeter. The similar sort of problem is actually encountered once in our lab. The wattmeter which was there was not working. But we have to perform this experiment. So then we thought of this particular method, that in case that sort of phenomena is there and wattmeter is not available, generally you should know that wattmeter is a costly equipment in compared to ammeter and voltmeter. Now in case I am not having wattmeter, I am having voltmeters only, then also we can find out the power measurement. Theoretically it is possible. Practically some error may creep in, but otherwise we may get pretty reasonably good results actually. So how we are going to do? Let us try to understand. This is what the arrangement is. We are having RLC, we are having the supply, that is the voltage V. What we are doing, we are measuring the supply voltage and voltage across R, L and C, VR, VL and VC. Now what we know, that P is Vi cos phi. Means in order to find out P, we know the information about the voltage, we know the information about the current, we know the information about the power factor. So we require these three parameters, but we are measuring voltage only. But from that we can find out the other parameters. Let's see how we can do it. Suppose I am trying to draw the phasor diagram of this particular arrangement. So from the previous discussion, actually, you will get some idea that if I am assuming some current I is flowing through it, then what we can say is that, let us suppose I am taking this I as a reference. Let us suppose. Now what we can say, what about VR? VR is voltage across the resistor. So that should be in phase with I. So let us suppose this is VR. Now what about VL? VL is the voltage across an inductor. In an inductor, current would be lagging. So therefore we can say voltage will be leading. Let us suppose this is VL. And we are measuring VC. VC would be lagging the current, because in case of capacitor, the current will be leading. So therefore voltage would be lagging. So let us suppose I am having VC is of lower magnitude. This is the value of VC we are getting. So you could see VL and VC, they are opposite in direction. So the resultant, what we could say, this should be something here. This should be VL minus VC. For the sake of simplicity, I had assumed that the VL is higher than VC. So this is the case where VL is higher than VC. This is the case actually we had assumed. Now if that is the case, so you could see VR plus VL minus VC is basically voltage across this LC combination. So what we could say, that the vector addition of these two will be the V, and this should be the angle phi. So theoretically this is what we are getting. Now try to understand from this thing how actually we could find out the different parameters. Note it down. We are having VR. So what we know, VR would be equal to I into R. Now externally, what we can do when no current would be passing through it, we can find out the value of R. So R is known to us. So from that actually, what we can write, that I will be VR by R. So we are finding out the value of I. And we are also finding out V. So V is known, I is known. Now what is unknown? This phi is unknown. This phi is unknown, and we require it, because otherwise we can't find out what is cos phi, what is sin phi. So now let us consider this angle. So can we write tan phi will be equal to VL minus VC by VR? Or in general, if I am going to write it, what we could write, phi is equal to tan inverse, let me write it here, which implies phi is equal to tan inverse magnitude of VL minus VC by VR, the magnitude. We can write in this way also. So we are getting phi. Now once we are getting phi, we are having I, we know V, so what would be the active power? P would be VI cos phi, Q will be VI sin phi, and S will be VI. So we can find out the power by using voltmeter only. Now comes the question that from the phasor diagram we are having it. Now how would be correlating the things? how actually we will be drawing the phasor diagram accurately so that we can calculate the result from it. Now from that, let me try to explain it in a simpler way for the sake of simplicity. Let us assume that this VR is say 10 units. Let us assume so. VR is 10 units. Then VLB say 15 units, let us suppose, and VCB 5 units. So how to draw the phasor diagram then? What we are going to do, we have to find out this angle in particular. This, let us suppose O, this is suppose A, this is suppose B. This angle is to be found. So what we would be doing, VR is 10 units. So what we are going to do, we are going to take a scale and draw, let us suppose 10 centimeter line, and we are calling it OA. Then VL is 15 units. So what I would be doing, VL would be 15 units. So I would be drawing it here. This should be 15 units. And VC is 5 units. So I am drawing. So it would be not 15, it would be 15 centimeter perpendicular. And this should be in the lower one, it would be 5 centimeter. Now the difference should be 15 minus 5, that is 10. So what we will be doing at this point, we will be drawing in a scale of length 10 centimeter, and straight away join this. So this length is known, this length is known. So automatically we can find out this phi. So basically this is the way we can find out the power measurement in AC circuit in lab as well. Generally this is the most easily available lab setup in everyone, and this may be done, but since it requires all these complications, so generally this method is not avoided. This method is actually avoided. So I had discussed the theory of the both. I would be doing the both of the experiment and show you the results, and we can see that the results obtained by two would be different. The reason for that is being that we are assuming ideal RLC here, but in the practical scenario, the RLC which are available, they might not be ideal one. This R might have some resistance as well as some inductance. This L might have some resistance, some inductance. This C might not be of perfect dielectric. It would be having some imperfect material there. So it would be some RC sort of combination. So due to which there might have some difference in the result that we obtained by two methods, but theoretically both of the methods are correct. So hopefully you will understand that what is the importance of power measurement and how basically we can have the power measurement even if we are having very limited resources with us. You have to apply the basics, and from the basics you could actually have all the readings. So I'm stopping here. If anyone have any doubt, you may ask me freely. Thank you. Have a nice day.